All right, everybody, I'm going to try to see if I can get this video done for you. A little bit of a disclaimer, I am actually recording lessons while I'm walking around in Tennessee, so if you hear music in the background, just ignore it, but listen to the problem solution. Okay, so here we go. All right, so a little bit of a disclaimer, there's a lot of stuff here that you got to look at. Make sure you read all of this stuff here. It'll give you a really good overview of what you're going to encounter on the exam. But let's kind of look at the very first problem here, number one. And so what I'm going to do is I'm just going to go really quick and try to give you the general idea to answer the question, and then you should be able to solve it. But I'm not going to spend any significant amount of time going into all of the little particulars and details of it all. Since we've already gone through about 3/4 already, you should be very familiar with most of this. Okay, but I will spend time explaining some of the stuff that needs to explain just to make sure you get it. So we'll begin with problem number one. Okay, problem number one is asking about solubility. So you are going to need your solubility table. So this is the table that we got right here. So remember, the way you look at this is you get the cation across the top, anion across the left on the y-axis, and you're looking essentially for SOL. If it's SOL, you're going to put it as an AQ. Okay. Okay, so let's take a look at this here. I'm going to move some items out of the way just because we don't need them for this particular portion of things. But if you look at this here, you've got a bunch of compounds, and what we want to make sure that we do is we just identify them on the solubility table, which is what I've got here. And so remember, just go through the top, identify the cation, on the left hand side identify the anion, and where they intersect is where you're going to find the solubility. All right, so what I'm going to do is just going to go down the list and identify them all first, and then just quickly identify them so you can see how it's done. And this is how you should be able to do it on your end when you're doing the exam. So the first one is sodium hydroxide. So notice sodium is here at the very top, and then hydroxide is OH, and remember where it intersects is where we want to be. So the first one is going to be soluble, so you want to go ahead and identify that as AQ. Iron sulfide is Fe and an S, and again here where it intersects, notice here in this case it's INSOL. So that means it's going to be insoluble, so it's going to form a precipitate, and that's going to be in the solid form. Aluminum phosphate, here you want to go and look at that at Al, and then PO4. Remember that PO4s, almost all of them are insoluble, and so you see that there, INSOL, and so you represent that as an S. All right, so the next compound here is lithium carbonate. So what we're going to do is we're going to go down the top here, go to lithium carbonate, and notice this one here is going to be soluble, so we'll represent that as AQ. And literally that's all you really have to do for all these compounds, is just repeat the same process and you'll figure them out. So I'll let you go ahead and do the E, F, G, and H on your own, but notice these are slightly different. You're going to have to translate the name into a formula. Once you get the formula, then you look it up on the solubility chart and you should be able to figure out its solubility. Okay, so I'll give you a second, go ahead and pause if you'd like, and I'll come back in a second or two and then give you the answers for those. All right, so here are the answers. I've already gone ahead and circled the atoms on the chart here in green. And so what we find here, if you look at this, copper sulfide, looking at that there, copper sulfide is insoluble, so this is going to be a solid for that one. The copper nitrate is soluble, so that'll be AQ. The magnesium carbonate is going to be insoluble, so that'll be a solid there. And then the sodium acetate here is going to be soluble, so that'll be AQ. Now, one thing I'll share with you here is when something is AQ, remember AQ means aqueous, and this is going to be that you're going to form ions. Okay, so this is extremely important for you to remember. Okay, once you figure out the ions in the later problem, you're going to see how many ion moles you're going to generate, but at least identifying early on that you're going to form ions, that's extremely important at this point. Okay, so let's move on to problem number two. All right, so let's take a look at problem number two. Number two here, if you look at this, let's move this out of the way here, this particular item here, smooth that out. But if you can see problem number two is asking you here, are you going to form a precipitate? So some of the problems I'll ask you on the exam are going to be giving you two compounds. You decide if using one of the 5 different types of reactions, single replacement, double replacement, are the most common, and then you determine if the precipitates form. You do need to use the solubility chart. So essentially, let's go ahead and do this here. We're going to have to translate. All right, so let's go ahead and translate this. I'm going to go ahead and start it here for you, and then notice here we got to make sure that we focus in on the actual words. So let me underline them. Here's a word, here's another word, and it's asking you, is a precipitate going to form? Remember to look for the key words, reacted with. Obviously that means it's going to be plus, and then obviously here we're looking for the product, so you got to make sure that you kind of predict it. So let's kind of do that. So calcium phosphate, remember the calcium is Ca, and then the phosphate is PO4. The rubidium is Rb, and the hydroxide is OH. And you want to go ahead and add the charges. And so that's a +2 here, it's a -3 here, +1, and a -1. Now remember when we did this, we always had to check the charge. We have a neutral charge overall. So the first compound that we can actually get to like that is this one here, RbOH. This is a neutral compound, so we're just going to leave that like that. But here on the calcium phosphate, we're going to have to actually do the crisscross method here. And we're actually going to have the following: Ca3 parentheses PO4 with a 2. And that's going to react with this other compound to form the product that we want. So go ahead and make the prediction, and then we'll see what we get at the end, and then we'll use that on the solubility chart to see if it's soluble or not. So here we got the calcium being positive, so I'm going to go ahead and split it here and split it here. Positive and negative, positive and negative. You make the prediction. If you look at the here, if you use the actual activity series, we're going to have to look it up. And so here on the activity series, you see that calcium is actually at the very top here. And so if you look at that, calcium's right here. And then the rubidium, it's not, let's see here, rubidium's not going to be here, but if you look at the periodic table of ions, what you're going to find is that rubidium's a little bit lower on the list. So calcium will definitely be the one replacing. Okay? So let's go ahead and move this out of the way. I'm going to go ahead and erase the highlight I did so I can actually move this out of the way. So we'll move this out of the way. So the first prediction here is going to be that calcium will come in and combine with the rubidium, and then not the rubidium, but the hydroxide, and then the rubidium will come in here. So the predicted result is the following. All right, so let's kind of look at the product here. These are the products that you should have gotten here. Remember to add charges. So this is a +2 here, a -1, +1, and a -3. So you got to make sure you do the crisscross. You're going to have 3 copies of the rubidium atom, and then you're going to need to have a 2 subscript on the hydroxide. And then just go ahead and look these up on the solubility table, and you should be able to figure out if it's going to form ions or not. All right, so let's take a look at that solubility table. If I bring this table down here, we can see if we're doing here for calcium hydroxide, we're going to be looking for the following here. We're going to take the calcium, and then the hydroxide. That's going to be slightly soluble. So this particular compound here is going to be slightly soluble. Okay, so that means that you're going to get some precipitate forming here. And then if you look at the rubidium phosphate, the rubidium, there is no rubidium in here overall, but notice the phosphate. Now if you look at the periodic table, you're going to find the rubidium is in the first group. And specifically, let's just bring up one of those periodic tables here. Okay, so here is that periodic table. Let's bring it over. Notice here for the periodic table, what you've got here is you've got the rubidium here at the bottom. So the closest element that you've got is potassium. So we can look at potassium as a way to tell us kind of similarities of the overall element. And so let's kind of do that and move this out of the way. Okay, and so that means that rubidium then will be close to potassium. And so if we go look at that, we've got potassium here, and we've got phosphate, and so notice here this one's going to be soluble. Okay, and so this here for the rubidium phosphate is going to be AQ. So the one that's actually going to generate some ions is going to be the calcium hydroxide. Okay, and so let's just move this out of the way, move these things out of the way, and so here the calcium hydroxide is going to be a solid. Now, not all of it is going to turn into a solid, but some of it is, and that's why you got to make sure that you are aware of that. So just make sure you put the solid there. The other item that you want to make sure you do is identify here AQ on the rubidium phosphate. So if we zoom out here and take a look at the question one more time, which one will form the precipitate? Well, the answer here is going to be the calcium hydroxide. Okay, this here is the precipitate. All right. So let's take a look at the next problem, number 3. It's the same type of problem here. It's just asking you which one's going to form a precipitate. Let me go ahead and erase some of this here so we can see the problem clearly. What we've got here is that we've got the question asking if you have calcium iodide, if you react that with sodium hydroxide, is it going to form a precipitate? And if so, identify the identity. Okay, so I'm going to give you a chance to go ahead and do this on your own, and I'm going to show you how to do it here quickly. Okay, so go ahead and press pause, and I'll come back with the answer. Okay, so here's one of the compounds. All right, so here we've got calcium, that's a +2. Iodine here, it's a -1. All right, it's reacted with, so there's a plus sign, and then we've got sodium hydroxide, that's Na +1, and then your OH -1. All right, so what you got to do now is you need to make sure that you look at the which atom is the one that's going to cause the attack first. And so we look here, not this one, but rather we look at this, and we see between them calcium and sodium. Sodium is just underneath calcium, so the one doing the attacking here is going to be the calcium. And so that calcium here will come in and attack the hydroxide, and then the sodium will attack the iodine. And so overall what you're going to wind up getting here, let's move this out of the way, the products that you're going to form is going to be calcium hydroxide, and then you're also going to get sodium iodide. Don't forget to put the charges, +2 here, -1, +1, -1. And so you kind of saw me here try to do this already, put the parentheses around hydroxide, and you need a 2. So if you look at the previous problem here, we know that the calcium hydroxide is going to wind up giving us a partially insoluble compound. So this one here is going to be represented as an S. But if you look at the sodium and the iodide, and we can do that over here, let's just bring the form up. Sodium and iodide here winds up giving you here and here a soluble solution. And so that one there is not going to be the thing that we want in terms of precipitate, so this one gets represented as AQ. And so there it is. So the one compound that actually does generate ions is, again, calcium hydroxide. All right, so let's go ahead and move on to the next problem. Let's go to number 4. This is a very simple thing. We just got to verify that you understand what the difference between SOL, ion SOL, and slight SOL mean. And so remember here, SOL is just a short abbreviation for soluble. Okay, and soluble means that it's going to dissolve. So I'm going to say here will dissolve. And slightly insoluble is similar to it because some of it will dissolve, but it's only a little bit. Okay, and so here when you actually report this one here, you're going to actually report it as a solid. The soluble one right above gets reported as AQ. And then the insoluble here is going to be represented as a solid here because completely all of it is not going to form ion at all. You're actually going to get a precipitate. So that's what that is asking you to do. So it's just more of a definitional thing for you. So just make sure you can tell those apart. Okay. Let's move on to problem number 5 here. Identify the following compounds, whether they form ions when they mix with water. This is going to be very similar to what we did already in the previous first 3 problems. And so here, what's important to pay attention to is going to be the coefficient at the beginning. And so let's kind of bring those 3 problems here. Notice here in problem A, we've got a coefficient of 3, which means that you've got 3 copies of LiOH, 3 of them. And so that's important overall. And so all you have to do now is just look at the solubility chart to determine whether they're soluble or not. Now, I won't spend any time here showing you the chart again, but you should be able to look it up and quite easily find out if it's soluble or not. And so let me just share the solubilities with you, that way you know what it is. Okay, so what we wind up doing here, let me just put this over here to the side. The first one here is going to be soluble, so you're going to report that as AQ. The second one, potassium nitrate, that's also soluble. Now it's the last 2. Notice the phosphates. These phosphates are the giveaway. Phosphates generally are going to form insoluble compounds in water. So that one's going to be showing up as a solid for C and a solid there for D. Now, that's just part of the solution here, or part of the problem answer. What you need to make sure that you understand, because the question is asking you how many moles are going to be produced. So you really got to pay attention to that coefficient. And so here, if each one of these 3, going back to 5A, lithium hydroxide, since each of these is going to break up here at LiOH, you're going to get forming for every one of these LiOHs. Essentially just get broken up into a lithium ion and a hydroxide ion times 3. So that means if I put the 3 up front, that means I'm going to have 3 moles of lithium and 3 moles of hydroxide. This is the answer for part A, respectively. Now you should probably just go ahead and put MOL for each of these to clearly identify that that's what you've got. Now for B here, let me just make an arrow and then put it down here. Here the coefficient is a 2 of potassium nitrate. We already know that it's going to form an aqueous solution, so it's actually going to break apart here at the potassium nitrate barrier, which means that you're going to form 2 moles of potassium ion, and then you're also going to form 2 moles of nitrate, and that's a -1 charge. So just keep that in mind here. Now with C and D here, we've got copper phosphate. The main distinction between these two, since it's the same compound, is going to be the coefficient. If we look at C, for example, that means you've got 1 mole of CuPO4. And so remember here, to make sure you get the right formula, it's a -3. This is going to be a +2. So you're going to need a coefficient of 3 here and a 2 there. And then this is going to be in contrast to the second one, which is going to be 2 moles of copper. And then here again, 3PO4 with the parentheses, 2. Okay, and so the one with 1 mole is going to give you 1 mole. Let's go ahead and write this over here to the right-hand side. It's going to give you here 1 mole of copper ion, and it's going to give you actually 3 moles, not 1. 1 times 3 will give you the 3, but then you're going to wind up getting 2 moles of the phosphate ion. Make sure you write them down as ion form. And then on the other side here for the D, you're going to wind up getting here 2 times 3 will give you 6 moles of copper ion, and then you'll wind up getting 4 moles of phosphate ion. Okay, and that's how you do the number 5. So if you have any questions on that, obviously rewind or come and see me during tutorial. All right, so here's where we're going to get into the nitty-gritty. Number 6 and beyond is going to be stoichiometry problems. So it's really important that you kind of look at these. The main thing to pay attention to here is, do you have a limiting reactant problem or not? Now, you don't have to use the grid that I provided here. You can always use dimensional analysis. In fact, that is the preferred method. So what I'll do here quickly is I'll show you how to do it using the grid, and then I'll move aside over here and show you on the right-hand side how to do it using dimensional analysis. First thing you want to do with everything is make sure you look to see if it's balanced. And so notice here, the word, it does tell you that it is unbalanced. And so one of the things that you want to make sure you do that is always pay attention to that, balanced or not. If it's not, balance it quickly. So go ahead and balance it, and we'll be right back. Okay, so here's the balance equation, and all I'm going to do now is I'm going to go ahead and put in for information that's provided in the problem. Notice here we start off with 9 grams of water and 5 grams of PCl5. Both of these are reactants, and so that's what you want to do. Remember here, the units that you've got are grams, molar mass, moles, half for H, and then we'll fill in the rest as we need them. Since we are going to need to go a little bit further, let's just go ahead and do that now. That means you're going to have moles needed, and then you're going to try to figure out if it's excess. Okay, and so here are the numbers that they give us. We've got 9 grams, 9.00 grams of H2O, and then 5.00 grams of PCl5. So the first thing you got to do is convert the gram units into moles, and so in order to do that, you need to get the molar mass of each of these compounds. And so you want to be as accurate as possible, and here's the information that you're going to need. So go from grams to moles first, and this is what you should get. All right, so here's what you should have gotten. You should have gotten 0.024 moles of the PCl5 and 0.499 moles of the water. Now, what you need to figure out now is, as with these as starting points, you do need to figure out how much of the other compound you need. And so in order to do that, here you need to start with one of these. I'm going to go ahead and just select the first one here. I'm going to select this one here in green as my starting point. Now notice the ratios here. We've got a ratio of 1 to 4. So whatever the amount of the first compound, since I'm starting with PCl5, I'm going to need 4 times the amount of water. So the easiest way to do this is just multiply by the ratio. In this case, it's 4 over 1, or 4. So 4 times the 0.0240 should give me the answer that I want. And so that number should be the following: 0.096 moles. And now the other thing that we're going to do is go the other way around. This time we're going to start off with 0.499 in red. And notice here that the ratio here between the PCl5 and the water is that since we had 4 times the amount of water compared to the PCl5, that means that we need 4 times less PCl5 than we do water. So we need to take this number here and divide it by 4. And that will give us the other number for the PCl5 in terms of how much PCl5 we actually need. And so that number should be the following. And so now the main thing here to figure out is which is the limiting reactant. We got to figure out here, take the moles that you have and subtract from it the number of moles that you need. Now, it's fairly easy to figure this out here. If you look at the PCl5, you don't really have enough. You're going to wind up getting a negative number here. Okay, so this one here, about 0.02 minus 0.1, that clearly is going to be a negative number. And so what you want to go ahead and do is just mark that as limiting. Okay, now the other one is going to have excess because notice here you have 0.499 moles of water, and that's quite a bit. When you subtract the 0.096 to that, you're going to wind up with a positive number, and that positive number is going to give you a difference of 0.403. This is moles of excess. So if the problem asks for that, you should be able to get that really easy. Okay, so now that we've gotten this side thing, this calculation done, let's kind of look at the individual questions to see what exactly we really need to know and answer before we go any further. First question is asking for the sum of coefficients, and this is going to be for all of them. So this is fairly straightforward. All you're going to do is add up all the coefficients. That means you're going to add 1 plus 4 plus 1 plus 5. And so in this case here, you're going to wind up getting a 5 plus 6, which essentially is a total of 11. So that's that one. Now, part B is asking us which reactant is limiting. We already calculated that. And so we know here that the limiting reactant is going to be PCl5. And how many grams of HCl would be produced? That's the actual question you need to figure out now. And so here we're just going to label this with a question mark to tell us kind of where we need to go. All right, so the easiest way to kind of figure this out is kind of go back to whatever the limiting reactant was, and we found out that that was PCl5. What you need to do is use the number for the moles half, which is 0.0240, and use that to get the number of moles of HCl, since that's the compound that you're actually after. Notice the ratio. The ratio here is 5 moles of HCl for every 1 mole of PCl5. So clearly here what we need to do is multiply by 5. So if you want to set this up in terms of dimensional analysis, that's slightly different. And so what I'm going to do is I'm going to go ahead and do the work down here, down below, so you can see that done. So if I start off with 0.0240 moles of PCl5, the dimensional analysis would ask me to kind of consider here. So for every 1 mole of PCl5, I'm going to produce 5 moles of HCl. Okay, and so you can clearly see here in this calculation here, you're going to take the starting amount of 0.0240, and you really are going to multiply by 5. Okay, and so when you do that, this is the following numbers what you get in terms of moles. You wind up getting 0.012 moles of hydrochloric acid, and all that's really needed at this point is since we're going to go in the upward direction, we're going to have to multiply that by molar mass. So go ahead and calculate the molar mass for the chlorine and 1 hydrogen and add them together, and you should end up with a number of 36.461. So go ahead and take that number there and multiply by 0.012, and what you wind up here is with a 0.437 grams of HCl, which is actually the answer here for part C. So if we come down here, let's go make some room here. Let's erase some of this so you can see it written down, clear up some space. And so the answer here for C is 0.437 grams produced. And it's a good idea to always write down the word that describes what's going on here. In this case, we're having a production of HCl, so you want to put produced. Okay, so what's the molar mass of each of the reactants? Well, we've already calculated 3 of them. The only one that we haven't calculated for is the other compound, and that's the compound right here, which essentially is phosphoric acid. So go ahead and calculate that little thing here, that molar mass, by taking into account 4 oxygens, 1 phosphorus, 3 hydrogens, and you should get the answer that you need. Okay, so that answer there here for that, the molar mass of each of the reactants, like I said, you've already identified the molar mass for all 3 of them except for the phosphoric acid, and we figured out that one there already. The molar mass is 97.994, and then the units are going to be grams per mole. Okay, Let's look at problem E, what mole ratio we use to determine the amount of HCl produced. We already did that overall, and I showed you the dimensional analysis here, but the mole ratio in particular is going to be the number of moles of hydrochloric acid to PCl5, and then don't forget the numbers here. It's 5 moles of HCl for every 1 mole of PCl5, and so that's the answer there for that one. And then how many moles of HCl were formed? We already answered that one as well. We learned that that one was 0.12 moles of HCl that were produced. And then the molar mass of HCl, again, when we were trying to figure out the mass of HCl produced, we found out that that answer there was, let's move this up a little bit. We figured out that that mass was 36.461 grams per mole of HCl. All right, and so this is the way you kind of solve this problem. Keep in mind that if you're using the grid, it actually helps out quite a bit. But remember, I am going to ask you how to do some dimensional analysis. So you should definitely use that method and be very comfortable in using it. Okay, and so that was number 6. Let's go ahead and turn our attention to problem number 7.